Hi, I'm Lisa Price, and in my commentaries I promised that I will make a movie about the possibilities of a low temperature disconnect switch for solar systems. And for that I would like to talk today just about the components we need, so you can start shopping and buy yourself the parts you need. I am not sponsored by anybody. I don't do that professionally. This is my first time. So please bear with me, and if you have ideas how I can make things better without spending money or too much time, then I would really appreciate your ideas. Put them in the comments, please. So we are talking today about just the components, and the main component to switch the solar system, the solar cells off, to stop charging your lithium batteries, because it can harm your lithium batteries if the temperature is under 0 degrees Celsius. So if you get the temperature lower than 0 degrees Celsius, then you get freezing, and that can destroy your batteries. For that reason, it's good to have a disconnect switch. To my knowledge, there is nothing like that on the market right now, and there's a reason for that. And let's talk about a BMS. A BMS disconnects the inverter from the battery when the battery has too little voltage. But even when the BMS has disconnected the inverter from the battery, the charge regulator, the solar cells, they still stay connected to the batteries. They are not being disconnected. That happens through the snubber diode. So we must let's think about a snubber diode first. What is a snubber diode? Everybody knows what a relay is, and a relay is a coil, a very tiny coil that creates a magnet, an electromagnet, and that pulls the switch, and then the contacts close. But in the moment it lets go, in that moment this little coil induces a very high voltage, and this high voltage can destroy your semiconductors on your electronic devices. So to prevent that, they parallel between the two contacts of the coil on your relay a snubber diode and this snubber diode conducts current in the opposite direction. So when you switch off your relay, then the high voltage is induced, and when it's induced, then the diode will transport this current back to the other point, so it will not enter your circuit. This protective diode, it's just a regular Schottky diode. This is it's mostly parallel to every transistor device or transistor to protect this transistor, and that is one of the very important things to make sure your IGBT, that's what we talk today about, this is this switch here, your IGBT will not get destroyed. And solar cells, we are switching high currents and maybe even high voltages. So if you buy an IGBT, go to eBay, you find those bricks online, and you can buy them on eBay used for a couple of bucks. I bought this IGBT for $20. It can switch up to, I think, 250 amps, and is rated for voltages, protective voltages when it's off, when it's disconnected, up to 2,500 volts, I think, or 2,000 volts. So I'm very much on the secure side for $20 with that switch. So let's have a look at this switch and see what it does. This I'm having here a little a transformer, and I have a multimeter. Let me switch on the multimeter. So now the multimeter is on, have it working, we measure 14 volts. I have 14 volts now on this IGBT. It comes out here, goes to the collector of the IGBT and comes out of the emitter of the IGBT, goes to the lamp, and then goes to the negative pole, goes back in the transformer. So very, very easy, nothing special. So then we have the basis or the gate. With IGBTs it's called the gate, and the gate is where we put our current to close our switch. So let's have a look at the gate. I think the gate is this little pin here, and nothing happening. Put my finger there and look at this. The light comes on just by this little current that's going through my finger. But what is interesting, let's look at this. The light stays on even if I take my finger off, and that's the charge inside this IGBT stays, and it keeps the gate closed. It keeps the transistor closed, and so the current can flow. So if I touch a negative pole and look, it's getting off immediately. Positive fall here, coming back on. So what an IGBT does not like is to be in an intermittent position. So it wants to be completely closed or completely open. And every IGBT has a switching voltage. So the secure switching voltage for this IGBT is 15 volts. And the secure voltage for switching off the IGBT, and you see here it's not doing it, is negative 9 volts. 0 volts, it's not really secure to switch the IGBT off. So that's why we often have a driver for those little IGBTs. And these drivers are little chips. They produce a negative voltage, and with that we can switch this device. So we have the muscle to switch our solar cells, to disconnect them from our charger if the temperature in the battery is below 0 degrees Celsius. And this is what you guys need to buy. Buy one of those units. They are cheap. You get them on eBay. It's an N channel, and it costs between 10 and $30 used. So that's one piece we need. Now, if we disconnect the solar panels from the charger because the temperature of the battery is below 0 degrees. So if we disconnect them, and the sun, we have a steel clear blue heaven, and the sun is shining on the solar panels, and we have the solar panels disconnected from the batteries, then we could get very, very high voltages on this contact of the solar panels, can go up over 1,000 volts, and this is very dangerous for any electronic device there is. So we have to prevent that, and to prevent that, we have to keep a load on the solar panels even when we have the solar panels disconnected from the charger. So there are 2 points. One point is the sun comes up, we reconnect, the sun comes up, it's under 0 degree, we are not allowed to reconnect, but we have to keep the voltage low so we get not in these dangerous areas. What we do is we can't use this energy because the batteries are cold, so we use it in another way. We heat the batteries with that energy. For that, we need another device, and this device is an SSR or a SSR. There are 2 SSRs. And these two SSRs, they're a little different. The one SSR can switch AC, and the other SSR can switch DC. This depends on your decision. Which energy do you use to heat your batteries? I decided to use a DC SSR to switch to use the energy my solar panels are producing. These are two components you need to buy as well on eBay. These two components are just relays, but they are electronic relays. And it's always good to have them at home, a couple of them, because they are very, very useful. Okay, so it's always good to have a couple of those in the house. All right. So these are the three muscles we need. These are controlled by a brain. This is an Arduino Mega. This is an Arduino Mega that is really overkill. What you need is a really small, tiny, smallest version Arduino for, I don't know, you get them for $3 or $5 online. You don't need to know how to code. I give you the software, the code. I attach it to the next video. We don't talk in this video about that. I give you then the code, and you can upload it to this unit. There are the contacts. You contact your pieces to it, and you are done. You are in business. So we have the brain. The brain does a couple of things. It does, for example, it can, if the batteries get too hot, it can switch on a cooling system. The cooling system can be 110 or 220, then you would use one of these units, or it can be a DC thing, then you use one of those things. If it's cold enough, it switches the solar panels back on. If it's too hot, it switches them off and cools. Then comes temperatures between, I think it's between 35 and 9 degrees Celsius, something like that. In this area, it just switches the solar panels on if the voltage is above the battery voltage, less 1 volt or something like that. That means it switches when there is no difference between the battery and the solar panels. So we have really the best switching point we can have. When it's under 9 degrees, it keeps the IGBT on, but it monitors the temperature. And if the temperature is between, I think it's between 4 and 9 degrees, at 4 degrees it starts the heater and heats it back up to 9 degrees, the battery. So it oscillates between 9 and 4 degree back and forth and keeps the batteries warm. The night comes or the voltage drops too far down, and the heater gets switched off, and the IGBT gets switched off. Then it's getting cold in the night, it's getting freezing, the batteries are getting really cold, it gets colder than 3 degrees, let's say they're minus 3 degrees Celsius. The sun comes up, the unit gets electricity, starts measuring, sees it's under 3 degrees and does not switch the IGBT on. But there's energy there. The sun is shining in the meantime, so it switches the heater on, and it heats the battery up to, I think it's 8 degrees or something like that. And if it reaches 8 degrees, then it switches the IGBT on. So if it's freezing, you will not lose a lot of energy. It takes maybe half an hour to heat up the batteries. It depends on what kind of heater you put on this. So it takes a while, and then you can charge your batteries with the sun even if the temperature's under 0 degree. And that is what this brain does. Yeah, that's basically it. and in the next movie we start to build this. I wish you all a nice day. Bye.